In this section, we're going to talk about z-scores and percentiles, and we'll also see this thing called the empirical rule. Let's start with z-scores. What are they? So when we speak about z-scores, we use them as a way to kind of see where we can reference things in terms of how far below or above the mean something is. So maybe we're looking at an exam score and we're trying to figure out how our score compares to others. So if our score is below the mean, we might want to know how far below. Are we in the top 5? Are we in the lower 5%? So we can talk about percentiles with this as well, but let's just start with this z-score. So we're going to take a look at how we can measure the position relative, or like a relative standing of a particular data value in our data set. That's what a z-score is. So it's calculated by taking whatever data value you're looking at in the data set, subtracting the mean, and dividing by the standard deviation. So what it's going to tell us is basically how many standard deviations this data value of interest is from the mean. So we could have a positive z-score, and that's when the data value is greater than the mean, and a negative when the data value is less than the mean. So when we subtract from the mean and then divide by that standard deviations, we can refer to this as standardizing. And so a z-score is just one example of a standardized score. So an example of this is, let's say we have two graduating seniors. We've got a marketing major and an accounting major, and they are comparing job offers. So the accounting major has a $55,000 per year offer, and the marketing major has a $53,000 per year offer. Well, here's some more information for each of these. So the mean for the accounting major is 56,000 with a standard deviation of 1,500, and the marketing has a mean of 52,500 with a standard deviation of 1,000. So we can calculate the z-score for both of these. So all we do for each is we take the corresponding data value, subtract off the mean that's associated with the data for that, and divide by the standard deviation. So notice both the accounting and the marketing each have their own mean and each have their own standard deviation. So we calculate each of that for whichever they correspond to. And this value that we get here is our z-score. So we found a z-score for both. So the z-score of 0.5 tells us that because it's positive, it's about 0.5, not quite 1, half of a standard deviation above the mean. And we also see that the accounting z-score is negative 0.67, which means it's below the mean, but a little bit further than half. It's 0.67. So as far as which offer is actually more attractive, we would say the marketing, just because it's more above the average. So these z-scores are pretty useful when our data distribution is symmetrical, bell-shaped. And if we find a z-score outside this interval from -2 and +2, we're going to see how this will only occur in about 5% of all cases. Therefore, a z-score outside the interval -3 to 3, even less, only about 3% of the time.